hopefully now that we have an idea of kind of what we mean when we say extrema, maxima, minima, we're going to talk about how to find and classify critical points, which will help us find maxima, minima, and that other type of point that I said we hadn't described quite yet. So what we have to do is we have to start with the z equal to f of xy. We've been doing a lot of problems where you have like x squared plus y squared plus z equal to 5. If you're given something like this, you need to move z all by itself on one side so that you have z equal to a function in order to start this process. So just a warning, you need to start with z equals f of xy. And that's so that you can calculate the gradient grad f of xy. And then you're going to solve for when grad f is equal to 0. Remember, the gradient is kind of like a derivative, so this is like finding when the derivative is equal to 0. You should be familiar with maximizing functions from Calc 1, that your first step is take a derivative, and then your next step is set it equal to 0. But I want you to remember the gradient is going to be a vector. You can't combine components of a vector from like unlike components. So you're going to end up with two equations, the one connected to I hat and the one connected to j hat equal to 0. Oh no. Sorry, that's a cat who just pulled down some curtains. Okay, and then we're going to solve equations from part 2. For all points x star, y star, where the gradient is 0. And then I just want you to be very careful. That means both the equations have to be equal to 0 at the same time. This is going to be a system of equations problem. And all of those x star, y star are your critical points. I'll just write right there that that's the word for what those points are, critical points. And then after that, you're going to classify, you're going to compute the discriminant d equal to f sub xx times f sub yy minus f sub xy squared. And then you're going to plug in all your x star, y star to your discriminant d to classify. And kind of the criteria for classification are going to be if d is greater than 0 and f sub xx is less than 0, that means that you're looking at a relative maximum. If d is greater than 0 and f sub xx is greater than 0, that's a relative minimum. If d is less than 0, right there, that's what's called a saddle point. That's that third kind of important point. I'll show it to you in a picture in a second, but real quick, I just want to finish these steps. If d is equal to 0, this method of classifying critical points is actually inconclusive. And all you can do from there is kind of look at what f of xy is, like plug in nearby values and the point you found, and then check whether it seems to be a maximum or a minimum. I'm going to put little bullet points there so you know those are the 4 different possible outcomes. And so these are the steps we're going to follow for every type of problem where we're asked to classify critical points. Real quick, I want to go back to this picture so that you know what a saddle point is. An example of a saddle point is right here, kind of at the origin. And I made a little triangle shape to try and denote that. It might look a little too similar to a star if I don't shade it in. All right. And a saddle point is something you didn't have to think about in one-dimensional calculus, but you do now, because what it means is that it's locally a maximum in some directions and a minimum in others. Kind of informally, that's what's happening. And to show that to you, so between these 2 peaks, kind of there's this line. Oh, bad highlight of the line. Okay, there's this line kind of going down, and the origin is right at the bottom of that. So it seems to be a minimum compared to these values along this line. But between the 2 valleys, there's also a kind of line like this way, where everything's lower as you move away from the triangle point along this curve. And so it's a maximum compared to points in that direction. So right here at the origin kind of comes together something that's a minimum if you go one way and a maximum if you go another way. And the reason it's called a saddle point is because that exact same behavior kind of makes it look like a saddle. So kind of here's a saddle right there is what's happening. It curves up as you head towards the horse's head or back, and then it curves downwards along the horse's body. And we're going to do some examples where we get to classify points and find these different outcomes.